I love coming here. So much of life is about finding your people, and I spent a long time trying to figure out where my people were, and they're here.
All right, the door is shutting. You guys are trapped now. Okay. All right, let's get this show started. Is everyone excited to hear about C++ 20 modules? Yeah. All right. Okay, yeah, I'm going to talk about C++ modules, import CMake, mastering C++ modules. Maybe a little bit of an ambitious title. I don't know if anybody can master them, but we'll see what we can do. Okay, a little introduction here. I'm the guy, blank guy, CMake guy. Like people say, hey, that's the CMake guy. Well, that's the sandal guy, right? I run around in sandals. That's me running the Leadville 100 ultra marathon up in the mountains. And the kitware guy. I'm one of the 5 founders of a company called Kitware. And we do scientific visualization software. About me a little bit. So from 1990 to 1999, I worked at GE Research, their corporate research center in Schenectady, New York. And I worked in a computer vision group. And when I got there, I was fresh out of college and really excited to hear about this thing. I knew I was a C programmer, and there was this C++ thing. Like, wow, object-oriented programming with C. Like, this is really cool. And I helped move them from symbolic list machines to C++ on Solaris with Linux and Windows. And I kind of became the build software library guy, GNU, CMake, Auto Tools. It was kind of a self-preservation thing to get into software process because we always did demos in the vision group. And my boss would be like, when we'd do this demo, the people would stay up all night and we'd show it to some important customer, and then all right, it's done. And then, 2 weeks later, the boss would be like, hey, some guy's dropping by. It's real important. Can you show that demo you guys did 2 weeks ago? I'm like, sure. Oh, no, it doesn't work. What did these guys do? And I update, and then I'm up like all night, fixing whatever bugs all these people cause to the software anyway. So that's how I got into sort of software process, so I didn't have to stay up all night at work. And then in 1998, I helped start Kitware. I did lots of development, CMake, ITK, VTK. I'm mostly in management now. I'm looking for funding, pointy-hoed boss guy. So, people might call me the CMake guy, but, it's really a community effort. Lots of contributors. At Kitware, Brad King, Ben Bakel are obviously big, huge contributors. Craig Scott as well, it's not just Kitware people, it's a big community. And basically, I'd like to thank all of you for, using CMake and supporting it. That using it is supporting it. And we'll get to that. It sort of fits with the theme of the modules. Quick thing about Kitware, we built on open source software. We have a computer vision group, data analytics, scientific computing, medical computing, and software solutions. I like to throw this in presentations about CMake. People are like, where did CMake come from? Why'd you do it? Kitware is actually the lead engineering team for the creation of the Insight Segmentation and Registration Toolkit. So it's funded by the National Library of Medicine. And it was to codify the state-of-the-art in segmentation and registration tools for medical data. So MRI, CT, and they actually have this data set where they froze people solid and sliced them and took pictures, so they had reference data for the CT and the MR. So they created this big C++ library, and we were tasked with just, it's got to work cross-platform. The state-of-the-art back then was Auto Tools on Unix, checked-in Visual Studio 6 projects on Windows, and maybe someone knew how to get something working on a Mac. So I wanted to fix that, and I remember pitching it to the ITK group, and some guy from CMU was like, Bill, why are you creating the ITK build system? Can't we just use some standard thing out there? But before he let me answer, he's like, oh wait, you're not talking about creating an ITK build system. You're talking about creating a build system for the whole world and all of C++. I'm like, yes, world domination. Takes a long time to grow a standard thing like that and get that world domination, but it eventually got, thanks to everyone, I think, part of it was it was a very pragmatic project, and it still has, some leftovers from that. From day one, it built ITK, and a grad student could get in there and build ITK and write their own little project with it. The syntax was a little bit ugly, and it grew over time, and there's probably some mistakes in there, but it always worked, and it was very useful. All right, enough of the background. Let's talk about modules. Okay, this was a talk that Daniel Russo gave at Cpplusplus Now, talking about the challenge of implementing header units. So for the sake of this talk, I'm going to be talking about named modules only. It's sort of interesting, the header units were, hey, let's create this way. It'll be a way to use all the legacy code. But it actually taxes the build system and the tooling even more than the named modules. So like everything has to be perfect before you can get to use this legacy supporting thing. So maybe we'll never get those, but I'm hoping we do get named modules worked out, and we'll talk about in this talk. So I always have fun, 2023 I said, hey, ChatGPT, does CMake support C++ 20 modules? Sure it does, Bill. Here's how you do it. And it produced some gobbledygook CMake code. Doesn't really make sense, doesn't do modules, and CMake didn't do modules then anyways. So in 2024, I'm like, does it do it? It actually got some good text here. It's used the CXX module target type. It's not really a target type. It's a part of a header set, file set. And then it gave some, that's not the right code at all. That's building a shared module with mymodule.cpp. So what this tells me is there's not enough module code out there in the world to teach ChatGPT how to do CMake modules. So that's part of the goal of this talk, is to get people psyched about modules and to show them how to do it in CMake. And maybe in 2025, when you ask ChatGPT about CMake modules, it'll answer right. So can we all help train ChatGPT? All right, what's a module? Okay, so this is, to replace header files. So this is a simple module. I'm exporting module B, and then I'm exporting this function called B in this module. So pretty simple, and someone could say import B, and then they would be able to call this function B. And what happens is with that, when the compiler sees that module, it has to get compiled, right? This code gets compiled by the compiler. And as a side effect of that compilation, or with special flags, you can ask it to create the built module interface, or the BMI. MSC calls these .ifc files gcc.gcm, clang.pcm. Whatever. They're built module interfaces, and that's what I'm going to be calling them in this talk. And that's the nomenclature that Bryce and Boris came up with it, so that's what we're going with. Okay, so here's where it gets tricky for build systems. So look at this simple example. I've got my B module that we just had, and an A module. So B exports B, and A imports B. So we try to compile A, and I get an error. Can't find module B. This isn't C++. What is this? So with include files, this wouldn't be a problem because I would pound include. But now what has to happen is the order actually matters. So B has to be compiled, and that BMI has to be created before you can compile A. So if we look at it and we compile it the other way around, and we do B first and then A, voila, it all works. So now we've got a conundrum, right? It's kind of a chicken and the egg. Modules require the build system to know which file produces which BMI files and which ones consume them. So we're going to need to parse and compile the file to find that out. So what you're saying is we have to compile the code before we can compile the code. This is a tough problem. All right, but CMake actually has like 17 years experience with this problem because it's implemented Fortran modules. So in 2005, the initial makefile support for modules in Fortran, which are the exact same problem, was added to CMake by Brad King. In 2015, thanks to the Trilinos project, we created a fork for Ninja that handled dynamic dependencies. And in 2019, so you notice there's a gap there, 4 years, it took us to get that upstream to Ninja. And the reason why is Ninja people are like, Fortran? Who cares about Fortran? We don't care about Fortran, that's crazy module stuff. Then C++ came out and said, hey, we're going to do modules just like Fortran. Say, hey, Ninja guys, if you want to be able to build C++ in the future, you're going to be able to do this thing that we did like 5 years ago. And they're like, oh, okay, now we'll merge it. So, yay. We're having an impact. Modules are already having an impact. All right, so yeah, and that was this dynamic dependency. And the difference here is that, unlike header files, that it only matters the second time you do the build that it has the dependency information. We need to know during the build the graph is actually changing, because during the build we're collecting this information. We have to update Ninja after it's started. All right, so how does CMake do this? It has a Fortran parser based off of a tool called MakeDep F90. And previous to this, before this MakeDep thing, basically the way Fortran people built their Fortran code was just keep typing make over and over again, and eventually it'll converge and build everything, because you'll get one more module in a time. So and people had like shell scripts that would just do, while not error, keep running make. And they were really happy when we added into CMake. So it was like the only build system that seemed to care about Fortran. But we made these patches to Ninja, and we had this Fortran parser, but obviously we don't want a C++ parser built into CMake. It already does too much. It doesn't need to build C++ directly. Anyways, and then we have a dynamic dependency collator inside CMake that collects all this up and then builds stuff in the right order. So in 2019, Ben Bakel over there, raise your hand, Ben. Big hand for Ben. Started describing to the standards committee what they were getting into with modules, and wrote a paper describing how CMake does Fortran modules. And then eventually went on to P1689, which is a format for describing the dependency of sources, which has now been adopted by all the major compilers. Yay! So the way this works is you get your sources, and then you go through and scan them and create dynamic dependency information for each of the sources. So we go through and scan all the sources first in a target, and then collate them into dynamic dependencies for the target, and then we're able to build stuff in the correct order. So where we are today is the support for this dynamic dependency output is in Visual Studio. It's in Clang 16 and newer, GCC 14. CMake 28 has non-experimental support for named modules. CMake 29 has experimental support for import std, and I'll get into that more later, but we've made some progress. The CMake module able generators are the Ninja one and Visual Studio 2022, aka MS Build. Does have some limitations. The Ninja one has a little richer feature set, but we're working on Microsoft to fix that. All right, so back to this a.cpp. This is the output of the scan dependencies, implementing that paper that's just showing the compilers outputting it. And you can see that the primary module output, the primary output is a.object, but it also outputs a.ifc, that's that BMI, and requires logical name B. So now I know that A produces an A module and requires a B module. do the same thing with B, and you can see it doesn't require anything, but it does produce a B module. So plenty of information there to figure out the build order. Okay, now I'm going to digress a little bit. How many people know about CMake file sets? All right, I'd like to see more hands. How many people use CMake as their build system? Okay, if you're using CMake, you really want to look into file sets. They're awesome, cool, great way to do things. And you can like stick your head, and this is so here's a really cool example of this with header-only libraries with file set. So I've got my target sources on eigen, and I just say base dir source, and I give my list of headers. And then from this, I can install it, but CMake can also induce, what include flags need to be used at both build time and install time by doing this header set. This file set with headers. And if I run install, you can see it installed all those headers, and then I could, find package, and then it would have the right includes. So growing on that, we added the CXX modules, and this is important, and I'll get to that later, but since these BMIs need to be created in order to consume the modules, you have to sometimes ship the source code, and CMake needs to know how to build that BMI from your module file. So using the file set, you can put your modules in there as well. But I encourage you, even if you're not using C++ 20 modules, use file sets. Use file sets. You can use file sets now, right? Yeah, okay. All right, so let's look at a simple, the A and B. We have a file set, and we say type CXX modules files, and we've got our A.cpp and our B.cpp. And we run our configure step. Everything looks cool. And then we run the build, and I know this is sort of small, but you can see that it's running our, Clang scandeps format P16A9. And then you can see the collator running in here, a CMake -E command. And then everything builds, and I don't have to worry about what order my A and B came. I just throw that code in there. All right, so installing targets also in CMake now has a new feature. You can install the CXX modules BMI. All right, so all this scanning is expensive, right? And changing the build graph, and it could break parallelism. So we want to make it optional. So CXX scan for modules. It's a Boolean specified on. It's on for C++ 20 and higher. But if that's off for some reason and you try to use modules, you could run into trouble and sort of shoot yourself in the foot. So this should be on for any file that has an import or an export. In exporting targets, there's some module stuff here, CXX module directory. Okay, so let's quickly step back and look at the anatomy of a name module. So up at the top, usually you say module, semicolon, and this begins the global module fragment. And inside this section, this is where you can have all your header files and old header files and pound defines. Like you may have pound define turn on foo and then include foo.h, sort of preprocessor things. But one thing to note is that, remember, we have to ship this module outside of in our install thing, and it has to be compiled. So any header files that are in here, although they aren't in the module, they do need to be in your public interface because they're going to need to be around when later, after it's installed, and someone needs to build that BMI. So even though they're sort of private to the module and they won't leak out, they kind of leak out into the build system needing them. Okay, then the next thing you say, export module A, you're declaring the module. And after here, it's all module stuff. You say export this or export that. And have all your exports in there. There's some other features in here, but this is the gist of a module. So our global module fragment, note any headers in here. I jumped ahead of myself. Must be public because the module will need to be used when creating BMI by consumers. All right, so there's a cool web page out here that I found. It's called Are We Modules Yet? And you can see we're tiny on the graph, and our current velocity will be finished with all these by 2626. Woo! All right, fun times. So,
what's the set of things they're measuring?
Just if it does modules, if you can do import.
Repeat the question.
Oh, sorry. The question was what's the thing that they're measuring, whether they're modules or not? So they went through and looked at a bunch of projects, and just if the project produces a module such that you can say import project name instead of pound include. Pretty simple stuff. And they've got a little checkbox, so it's got a whole bunch of projects, And then you can check. You can see the little blue check is the status. And I checked the ones that had status modules. And then I went on an adventure. I tried building them all. So there's a bunch of them. I'm like, okay, so you're telling me there's a chance. We got 17 libraries with module support. Awesome. Let's go build them. Ta-da, let's go on the magical mystery tour. All right, so right now modules aren't for the faint of heart, but I'm hoping they're for everybody. All right, the most recent Visual Studio preview. You want to grab the most recent compiler probably if you're going to play around with modules because things are moving rapidly. If you don't like building a compiler, you should probably move to Microsoft Use theirs. They're actually really ahead of the game and have nice releases with support for modules. You can also grab yourself a copy of Clang, Origin Main, and be ready to build some C++ compilers. Fortunately, Clang builds with CMake, so I know how to build it pretty trivially. But you do need to turn on some options. You need to enable the Clang project, give yourself an install prefix, unless, because you probably don't want to clobber your system one, write it somewhere where it won't bother anybody. You want to build it release. And then you need to enable runtimes. And you want libc++ in there, especially if you're doing import stud, because you got to build the libc++ library. You want to use the Ninja thing because it's going to be faster. And then you run Ninja, and maybe in less than an hour if you have a nice new machine. Well, at least on my Mac, it's less than an hour. And then you're going to want to get yourself the latest CMake as well. We actually do have a nightly binary, I think, but it's probably best to build it yourself. All right, and then set yourself up an environment with all this so you can build it and point at your compiler, put CMake in your path, set an install prefix where we can play around with all these 17 projects. All right, the first adventure with compile time regular expression. I was excited to see this in the keynote talk mentioned. I'm like, all right, I got to work on this one first. It's mentioned in the keynote, and it's one of the ones that supports it. And so thanks to Hannah and Ben, we kind of hacked around on this. It's got a happy ending, and the pointy-haired boss me driving everybody nuts with my questions and, hey, why doesn't this work sort of stuff. Not quite as big an adventure as the 30-mile ultramarathon I ran last Saturday, but nonetheless, it was a fun adventure for me. And hopefully it's an adventure for you. All right, so I run it, and there's no install for modules. I do Ninja install, and I watch, and I don't see my module interface getting installed. Sadness. So I'm like, well, no problem. Let's test it out. I'll add just an executable. I'll hack up their CMake file, and I'll add a hello world project, into the project itself. Type Ninja, blows up. Like, sadness. Can't find module. I'm like, why can't I find the module? And I'm like, Ben, what is wrong with this? Come over here. And he's like, ah. All right, scan for modules was the culprit. And I'll get into that. So Ben quickly pushed up a merge request to the repository. And you can see up here, see how the minimum required changed from 3.14 ... 329. Hannah's like, why is the maximum 329? Ben's like, it's not a maximum. It's the, so it goes the minimum to the version. So this will affect the default, right? So it's telling CMake that the policies can go up to 3.29. It's not saying that's the most maximum you could use. You could use another one, but the policies can go all the way up to 329. And if the policy's new enough, then we can turn the scan on by default if we're doing C++23.
What's a policy?
The question is, what's a policy? And that is a mechanism that we have in CMake for handling new features that we add that might break someone's code or change things. We create policies in CMake, and there's sets of policies that get enabled with each version. So as soon as, and the way that users dictate that set of policies is by declaring their minimum required version. And this is saying this is known to work with 3.14, so it will work with that. But it will also work up to 3.29, and we can enable those policies. Anyways, so that was the culprit of why my thing didn't work, because it actually wasn't scanning for the modules, so it built that first and then couldn't find the module. Fun stuff. But you know, hey, Ben's a nice guy, and he added the installation rules for them. So then, you know, I wrote my simple program here with no pound includes that does the compile time regular expression, and I grabbed a little example they had of extract number, and we output the number. I wrote my CMake file that has, you know, minimum required 329. I did have to turn on the, right now import std is experimental. Someone asked me before the talk when that would go away. The answer is when GCC gets import std. Ben's nodding his head, so I got it right. Good job, pointy-haired boss. All right, so we've got, we say I want that experimental on. Then we've got our project command, and I'd say find CTR required. I add my little executable. I target link libraries private. And then I run it, and it builds, and I can see it run on my Windows Parallels VM, and I can also see it run on my Mac with Clang. So we got one. So exciting. Question in the back.
Sorry, I know this isn't the point of your talk, but I'm curious, since CTRE is a header-only library, if you measured the compile time differences when you did this.
The question is, since CTRE is a header time only library, did I measure the compile time differences with modules? No, I didn't measure them. And to some extent, I'm not sure modules are going to be the holy grail of making things fast, but I do think they're not going to leak information. I think they're a much cleaner way, and they're not going to put pound defines all over your code. And you know, I think they have other advantages over raw speed. I got a thumbs up in the back. You know, I can stop talking about this. Okay, all right. Please stop, Bill. Okay. You're going to run into some weird issues. This is one of the errors that popped up on me. And boom, you get an error from CMake that says CXX module std, property on target, requires that the CMake CXX23 target exists, but none was provided by the toolchain. All right, we're getting close to fixing this. It looks like it's a Mac issue. On Linux, it's working. But on Mac, I had to do this super hack to my CMake. I went in and hacked my CMake and told it, instead of printing out the file name lib C++ modules JSON, print out the file name ... lib C++ modules JSON, and that allows it to print out the full path to it instead of just the name. So there's some issues there. That looks like an issue with Clang on Mac. But this is a common error you might see if you start playing around with import std. And in fact, there is an issue for this in the CMake issue tracker. Someone's saying, hey, this isn't working. Now, there is an issue on the Mac, but there are other ways that you can get this where it's actually someone else's fault, not CMake's, or Clang, well, maybe it's CMake, but so this top one will cause that exact same error. And what I did is comment out the experimental turning on the feature. So the feature wasn't on, then I go to import something and it doesn't work. The other way it can happen is if I turn on the feature but do it after the project command, I'm going to get this same error. So, note to people trying it, this is one of the things you'll see. I think that's sort of important, and it kind of reminds me of, back in 1990 at GE, when I was first doing C++ and maybe 95 when they had templates, and you sort of got used to the errors that you got and learned how to work around them. Modules are going to have that same sort of thing, and you got to learn these things. So I'm trying to teach people the errors that you're going to see. This is probably one of them. There's a variety of ways it can happen. Some of them are your fault, and some of them are bugs in the tool chains. But essentially, it means that CMake couldn't find that std.module file produced by the compiler. And a lot of this kind of goes to, like, if you were writing your own modules for your thing and not import std, you would have a CMake file, or hopefully soon a CPS file, that described where to find your module stuff. But with the compiler, we've got to sort of grab it out of the compiler somewhere. And somehow that information has to get CMake. All right. So after playing around with all these 17 ones, I got 3 that worked. A lot of them compiled, I'll give them that, but didn't have the install step, so I tried to create that hello world version for all of them. So format, IP address, and semver. So I wanted to say, winner, winner, chicken dinner, but I was like, people might not know what that means. I'm like, you know what? I don't actually know what that means. I just say it. So apparently in the 1920s, in the Depression era, in a casino cafeteria, a chicken dinner was about $2, and that was the standard bet. So anybody that won got a chicken dinner. So there you go. Winner, winner, chicken dinner. We got 3 of them. All right, that was awesome. Other things I learned. I wanted to take a picture of Brett's badge. He always comes to these conferences. He's got treat your C++ like cattle, not pets. And I'd like to add something, maybe next year on my badge I'll have, treat your CMake code like real code, like proper indentation, and not like tabs that are this long. What is it? It's actual code. There's formatters that format it. You can have 4-space indentation, and it can look nice. It can be syntax highlighted. But a lot of the CMake code I looked at was pretty ugly. So work on that, guys. Treat it nicely. Come on. It's a first-class citizen. Also, be careful with versions of things. So pick up the wrong version of CMake, you're going to get some error. You're going to think, oh my God, this is broken. It's like, no, it wasn't. It was me. I was using the wrong version. Oh, I used the wrong version of Ninja. It's too old, and it doesn't handle something, and it blew up. Or the compiler. Remember that nasty hack I had? So I was like, oh, maybe if I get a new version of the compiler. So I built a whole new version of the compiler. But the previous version of that hack actually hard-coded the path to where that file was. So I was basically like, I had 2 versions of the compilers installed, and my CMake hack to look at the older one. And then I started getting really bizarre errors in like import std because they had changed some things. So be very careful. Otherwise, it'll start vomiting some not so useful errors at you. All right. So it sounds pretty horrible, but don't despair. Code, right? This is an engineering problem. I think if more people use it, the bugs will get fixed, things will get reported, and I think it's getting ready for people to really sort of dig in and get stuff going. And I'm excited about import std. I think this is really important, and it's going to pave the way. And I wanted to look at it. I'm like, well, how does this import std thing work anyways? What? Is it magic? Is it different than what I would do? And I actually found some interesting stuff. So let's take a look under the hood. Basically, it's a named module that's built around existing headers. Yeah, I wanted to find something. Look under the hood. This is actually after doing like a 15-mile trail run with my dog. I opened up the frunk of my Tesla, and the dog jumped right in because she thought she was getting in the car. So, or this is what's under the hood of a Tesla. A 90-pound dog. Runs really fast. I don't know. Well, let's look at modules. Okay. I'm calling it the import std model. So we can call it the Bill Hoffman import std model. But it's basically a named module for an existing library with little change to the existing code. And I had hoped to get to this before the talk, but I hadn't. I was going to try it with like VTK and try to do this, but I had so much fun and such a great adventure with CTRE and format and all the other ones that I didn't have time for that. But basically, you just need to create a module file, standard.cppm. But what goes in that file? What is in this file? So let's take a look at Clang. So remember I showed you sort of the anatomy of a file before. Basically, we got our module and then our section here with the headers that have pound-defined stuff. So we're including a bunch of stuff here. Looks pretty normal. You can say, see up here, warning, this header is generated by some Python script. That's interesting. And then we do export module std, and then the module stuff starts. So it's got a bunch of includes that include all of the std things with a .include file. I'm like, what's in there? So let's pop open algorithm include, and look at this fancy trick they're doing. Export namespace std, namespace blah, using std blah. So they basically pull everything in with using commands inside the same namespace. So, and they've got a Python script that goes through and parses their header files and generates this. So that's one way to do it, and that's how Clang's doing it. So then I took a look at MSVC, and they called theirs std.ixx. An extension for everyone. All right, anyway, so it starts off pretty much the same. We've got our global module fragment, module. Pound include a bunch of C stuff. And then export module std, okay. And then, what the heck is going on here? Pound include array. What sort of black magic is going on in Microsoft land? Let's find out. All right. Inside their file, they got this, looks like a macro sitting in front of their template for array called underscore export std. It's clever. Did the build, I had to build the module, and then I grabbed the compile command and added a -e, redirected it to a file. Let's see what preprocessed output looks like. Look at that. It's got an export in front of it. So essentially, they found a way to reuse their header files. Now, it did require that they had to go in and modify all of their header files for their project. But maybe this is a good design pattern if you want to provide. And then they could also provide an include version, non-include version. So this may actually be an interesting design pattern that people might want to try if they want to modularize their code. The other way, you kind of have to parse the code a little bit and do this using stuff. Clang guys love parsers, so that's probably why they have a parsery thing there, and it does all the using stuff. But this is interesting. I thought it was really cool. All right, so if you want to hear about import std, we've got a blog for it, import std in CMake 3.3, a new experiment starting. And again, this will get out of experimental once GCC has it. So I encourage you to go take a look at this blog. And let's look through the example that's in the blog. Basically, we've got to get our minimum required up to 329. And then we turn this experimental flag on with this hash that changes so that with different versions of CMake. Hopefully we get out of that soon, and we want to make sure we do that before the project command, before the compilers are enabled. And then we want to say set CMake CXX module stood, and this is a CMake variable that will initialize the target property CXX module stood on all the targets that show up in your project. So if you wanted to have import stood on or off in your project, you could use this global variable in CMake. And then we do target. We're going to create a library called uses stood. We have a question.
Yeah, I was just wondering, so obviously, like the experimental flag, that's a short-term thing, but is this like the set CXX module stood, is that expected to be long-lived?
The question is, the experimental flag is short-lived, and is the CMake CXX module stood going to be long-lived? Defer to Ben.
So, if right now the default is off, because that was a pattern one, eventually we will have a policy that will default to on for but I think it needs to be more widespread before we can turn it on by default.
Right, okay, so durable part of the organization, people won't have to think about it forever. Okay, cool, thank you.
So yeah, the answer was that it will be on, at some point in the future, it will be a policy that will turn this on by default. But right now, we want people to ask for it to be turned on. And at some point in the future, it'll be default for cpplusplus 20 enabled. Okay, and next we're creating this uses stood, and then we turn on the, privately we're using standard 23, but our interface is standard 20. This is to sort of show off how you can mix and match. And then we're going to add an executable, and we're going to have a main in there, and it's going to privately use stood. So note that the main.cxx itself will not be allowed to do import stood, but it's going to be out because it doesn't have the feature turned on. So we've got a simple example. Our uses std source, just prints out hello world, doesn't import stood. And then our main basically calls that hello world. And voila. Great thing to try it. I would encourage, if you're gonna, after you've built your compiler or got the Microsoft preview, give this a roll before you try it on your code. Try something simple. Start small, build up. Make sure you've set up your environment right. This definitely should work. And then we do the build, and you can see during the build, it's creating this lib __CMake _CXX23.a, which we had to actually compile a few files. There's some debate as to whether that's actually necessary, but it is actually necessary right now. So CMake creates this library that automatically gets linked, and then your BMI gets created for stood. So really, all I'm saying is give modules a chance. Try import stood, create a name module for your project with install rules. Be prepared to build compilers, CMake, and other tools, install previews. Be prepared for other errors because you're using the bleeding edge compilers and they may break your code. But I encourage you all to experiment with this and try it and try to get those numbers, right? I think, is it faster? Like what I want to do is take some of the libraries we have at Kitware, like ITK. Whoa, what just happened there? Okay, that was weird. Decided it didn't want to present anymore. Take something like ITK and create a module and import ITK, and then take some large project that uses it, and change all their include files to import ITK and see if it's faster. See if you like it, But the more people try stuff like that, the more bugs we're going to find, the more things are going to get fixed. And I think that velocity will fix. We won't actually have to wait till 26 to have modules in C++. Some resources. Shang Sui's really big developer in the Clang that's been really championing modules. Huge kudos to him. He's also got a Clang modules converter. You might want to look at that project. Essentially, it's a Python LLVM script Clang script that can parse files and generate some of these module headers for you. So it might be one way to experiment with your project. I didn't actually get time to try this, but it looks pretty interesting. And it's probably being used on Clang to generate that import std, or at least parts of it. You can read import CMake. The experiment is over to learn more about modules as well. That's on our blog. Also, Craig Scott wrote a really cool article, C++, 20 modules, CMake, and shared libraries. So if you want to be able to export symbols and work with shared libraries, you still have to do the declspec import export stuff on Microsoft and handle that. Modules don't solve that, right? I think a lot of people think modules are these magic things that are going to solve everything. It's just a slightly different way of doing things, but it doesn't solve everything, right? It's not a package manager. People are like, oh, it's going to be like Python. I'll just say import this and it'll work. It's like, no, we still need a package manager. It's just a cleaner way to describe interfaces and not have bleeding, pounding includes all over your code and stuff. But this is a really good article to read. I encourage you to read it and try the example in there as well. Some links for resources. A good place to look is inside CMake itself. There's the CXX modules examples. Also the test cases in there. If those aren't working for you or running, then hey, you probably got it wrong. Set that up first, make sure you've got that working. There's the import stood in CMake 3.0, the import CMake, the experiment's over, the modules converter, and the Craig Scott's thing. Special thanks to Brett Brown at Bloomberg for championing modules, Daniel Russo, Ben, Shang Shui. It's been awesome, and thanks for providing this adventure, and thanks to all of you for using CMake and building this community. It's pretty awesome. So with that, I think I'll end the talk. Thank you. There's my email. If you want to read more about CMake, read about how to create CMake build system, go there, explore the documentation. And with that, I will open it up to questions.
Hi, thanks for the talk.
You're welcome.
I believe that all the major compilers have said that they will allow import standard in C++20. Do you know if CMake's going to allow that soon? Because currently it forces you to have C++23.
Defer to Ben.
Yeah, so eventually,
Maybe just go to that mic.
Yeah.
So once import stood is out of experimental, we'll have an additional, it'll basically be a property on the target to say because all the compilers have, yes, committed to providing import stood in 20, we'll have a property that says, I want that extension. And then we can policy flip it at some point depending on how adoption goes.
Hey, thanks for giving the talk. It was very interesting. It's I was going to say at CppCon last year, actually, I remember somebody did some talk on import STD, and I was like, oh, this is cool. I got to try this out. This is going to be really awesome. And I had the same kind of experience where I then spent the whole rest of the evening trying to build Clang from source and the thing with LLVM enable runtimes, that took me a little while to figure out that I was going to have to actually build an experimental version of libc++. So I definitely understand the pain there. But very awesome to see as this kind of continues to mature. So I was going to say, it's great for me to kind of play around with Clang myself, but for me to actually be able to use this for real in prod, I am going to need GCC. And so I was just wondering, do you know what the timeline is for import STD on GCC? Okay, cool.
I can also tell that I found out that
Come on to the mic.
I found out that by Googling there is a bleeding edge available from June that supposedly does that. But unfortunately, I couldn't find any working example on the net, and then the post on Stack Overflow was deleted. So actually, it's a good question.
Talk to your GCC vendor about when they're going to merge patches. I am also curious when it's going to happen. I know it is being worked on, but I do not know a timeline.
No specific timeline.
Yeah.
Okay.
So you can look at this preview because I just looked at a GitLab log and they supposedly support it. And there were people saying, yeah, it worked. But I couldn't find an example.
All right, so there's rumors that it's working. People are working on it, but we don't really have a timeline and haven't been
Right.
communicating that well with the GCC
Yeah, but
developers.
assuming that we have like most recent CMake and then we have GCC 14, that would be enough to use our own internal modules, like within a single code base?
Yeah,
Okay, cool,
15,
awesome.
GCC 15.
Oh, that's when they'll have import STD. Okay, awesome.
okay, the word is GCC 15 will have it.
Even with GCC 15 having it, CMake still needs to understand that it is available and make it available.
Right, one of the reason it's still experimental is because GCC doesn't have it. And who knows what they come up with. It may actually cause some changes in CMake. And we're certainly going to have to teach CMake how to find it and consume it. So that, and hopefully it won't change any of the APIs, but you never know. So that's why it's still experimental.
Right.
But it should be coming out soon, I would think. So,
Yeah, cool. Thank you very much.
thanks.
Since we have a little extra time, I just wanted to put this out there. If anyone wants a cool open source project, write a Clang transform tool. Is this the one Chuanqi's doing, where you like do the includes and it puts the imports in there?
Yep.
Or, okay, I misunderstood because it sounded like it was the other thing you were talking about. The thing that Clang was doing, which is different. I was saying on the consumer side, I have a bunch of IOStream includes. Those are current experiments show that that's much slower than import stood. For like if you just plan including IOStream, because it pulls in all kinds of stuff that you have to parse, you're never actually using it. Whereas when the import model, the compiler actually knows which parts of that it really needs to parse that can kind of skip around.
Okay, so what you're saying is write a thing that will rip out all the standard headers and replace
so for
them
your
with import
example,
stud.
like write it with it, include IOStream, and then run magic Clang tool, and then it rips out the IOStream includes and puts the import studs in there. You can't just do a find replace. You need something that knows where to put those things.
Yeah, I don't think it's that.
Right.
that
So
exists.
somebody, I'm putting it out there for somebody, that would be a very impactful tool for the community, including for the libraries that we want to start modularizing things. Like they might like have modes where they use imports and things like that, because we eventually want that to happen. So then we have a question behind me.
That would be a cool tool.
A similar question to that. Thank you for the talk. Like we do in Python, like import module from, or we import function from a module in Python. Will that be a kind of a thing which we can see in later, like in C++? No?
No, I don't think
Because
so.
we don't want to import everything from standard.
Well, you can have partial modules, and depending on how you build your modules, right? You could break it down.
Yeah, you can have narrower modules, but importing subsets of modules is write an ISO paper, and yeah.
Actually, there's a talk by Daniela about modules where she actually went onto that question and basically said, like, you just want to do import std because it's so fast that you really don't want to have subparts in there.
Okay.
Just look it up.
Now, it's a question about the modules adoption, because as I understand, the syntax requires a certain level of compiler support. So how about all the libraries that won't like to be backward compatible? I understand there will be lots of preprocessor guards to say, oh, if the modules are available, then import is std. If not, this is the include list, right?
I'm not sure I quite got
Okay,
it.
how do I make a project compatible with modules and also backward compatible with includes?
Yeah, you'd
Is
have
there
to
any
use
standard
the,
way of doing that?
You'd have to use the preprocessor.
Yeah, in the standard, header units are supposed to do this, except that header units basically require all the work to be done before we can we support header units. So you can wait until everything supports header units, or you can, there's no good solution right now.
But in the projects on that I looked at, and especially the ones that worked, they had CMake options plus macro options in their code.
Right.
So there are examples of that in the working stuff that I found.
Thank you. I will look into that. Thank you.
Sure.
Check at the unit.
Yeah, thanks for the talk. That was very informative. Is there any to-dos open right now on the CMake side for named modules, or are you basically done and just wait for compilers?
Oh, there's plenty of to-dos.
Yeah, so there's definitely stuff to do. The next big thing is there's a flag compatibility issue with modules where the importer can set up the compiler state in such a way that when it imports a module, the module needs to be built in a compatible way. So for example, if you build a module with C++26 and you try to import it from something using C++23, the compiler may say, I don't know how to do this. So you need to say, 23 is going to import me, please rebuild the module with 23 instead. That is, currently CMake just assumes all flags are compatible. Eventually we will be making additional BMIs for each incompatible flag set from consumers. Build graphs will probably explode until people get their build flags under control. Hopefully this makes build flags more consistent across projects anyway. But that's the next big thing that needs to be done.
And that's actually a good question, because that was one of the issues I ran into and failed to make into my slides, is oftentimes when I wrote, the hello world, if I didn't have the same C++ standard in my hello world thing, I got a actually somewhat useful error from the compiler saying, hey, this BMI file was compiled with this, you're trying to do this, they're incompatible, it's an error. And then I went back and changed it.
It's also worth noting that because the properties of parsing that Bill described are true for anything that needs to parse modular C++. So another to-do was covered by Ben Bakel's talk this week about an advancement on compile commands JSON, in which we basically need to export an interesting subset of the CMake model into JSON so those tools don't have to implement a build system, right? So there will be work for that too, right?
It's merged and experimental.
So that's merged and experimental, but it's experimental, right? So that needs to solidify. We need some adoption by some vendors with real usage, get that feedback, iterate on the design, that sort of thing.
So I feel like I can finally be excited about modules. I've been holding myself back, so thank you for that. Really happy about that, thank you. Could either of you talk a little bit about what happens when you install a built module? How is that packaged in a way that the interface is exposed? So it's not, it seems like we're not including headers anymore, right? So how does a consumer of my library pull that in?
Oh, okay.
Yeah.
Go ahead.
So you don't have headers anymore, but you do have module interface units. You will likely also still have a split between the module interface and the implementation. Just A, for you don't have to parse as much still, and B, you're not shipping your code to your customers, because unless you're dictating what flags your customers must use for your module interfaces, they're going to build their own BMIs from your module interface units because of the flag compatibility issues.
Right. Again, look at import std. Right. So that's a great example of what it might look like to have modules in your library. And I had to go in and see the source code for that interface. And you can see it was including a bunch of files, and I could see what it was doing.
And realistically, you're either going to be using vendoring like fetch content or submodule, and everyone's using CMake, like everybody, or we get some advancement on the CPS project that Diego from the Conan team was talking about this week. And we're not even really working on module specs out yet, but if we want to have cross-build system interop at the packaging level, where like you can have a Meson project shipping modules to a CMake project, or whatever that looks like, we're going to need some research at that level. So expect for packaging a modular library to be some wrinkles unless everyone starts using CMake.
Okay, I think that gives me a little more clarity, but just to follow up real quick, so the module interface, is that in a binary or is it still the source? I guess I'm not
So
clear on that
you
still.
can install the BMI right now, and if your flags are compatible, you can use it. In future versions of CMake, we'll be able to detect that the flags aren't incompatible, and then we'll be able to recompile that BMI. Right now, they have to be sort of.
Yeah, so just a clarification on that. You can install the BMIs. Currently, CMake won't even try to reuse it. It's there for eventually, if we get a way to ask the compiler, hey, we have a BMI, it was built this way, is this compatible? Then we'll just, the BMI compilation command will just become a glorified copy. But right now, everything will rebuild the BMIs at all consumers. So.
Okay, that's clear. Thank you.
And just a note on the compatibility thing, like if any project ever uses any flag that's different than any other project, that looks incompatible with CMake. So like if we want something smarter where you're setting a -d foobar, but nobody else knows what it is, so it doesn't matter, like we're gonna have to have some kind of interop between the compilers and CMake to communicate that kind of thing. And we have some papers around that, but there's no active implementation that I'm aware of. And again, we'll have some kind of development cycles like we're seeing maybe 4 modules, hopefully faster because we're used to working on this stuff, where like we come up with a spec, compilers are required to dump certain kinds of JSON files or something, and then CMake can pick it up and say, oh, okay, well I need 3 flavors of BMIs for this import, and I know which source files need which flavors and that sort of thing.
All right, and with that, we're sort of out of time, so go forth and import std. Thank you.